So today mm, I'm going to discuss about QEMU and let me share the presentation and so this is a quick emulator and this emulator, that benefit of this particular emulator is that if you don't have particular hardware architecture, if you want to have a look on that, and sometime if you want to simulate your application, and if the platform is supported in this QEMU, then you may test in the simulator first. And also we will look into that bootloader overview, and I will take example of this x86 booting mechanism with QEMU, or with in one particular example I will use USB boot also, and how this BIOS to boot sector code transfer demo that will be done in both QEMU and USB based, and uboot demo with this QEMU. So let me go through this next. So before we proceed, that this particular presentation has a disclaimer that will be not responsible for any damage to USB or hard disk due to experiments followed. Take a note of all the instructions carefully. Don't use your hard disk for bootloader experiments. And I am using either this QEMU or old x86 based system. So basically I am utilizing my old x86 based system as a you can think of some sort of advanced embedded system kind of stuff. For example, it has PCI interfaces, it has Ethernet, and anyway that core is also, I don't have to do cross compiling. I can manage with the native compiling. So that's why. And additionally, I believe that this architecture being taught in most of the engineering colleges, so that it may be helpful for students also in India. And so what is this QEMU? Is a generic open source machine emulator and virtualizer. So based on this use case, whatever I'm taking x86, the idea is not x86. Idea is to use the QEMU, familiar with this QEMU, so that you can emulate other uh, boards also. For example, Raspberry Pi, you can see RISC-V based system also, you can have a feel in this QEMU up to certain extent. And so what it does, if it set as a emulator, then emulates program written in one architecture in another. So for example, in case of ARM based simulators or MIPS based, so MIPS program written in will be emulated in the x86 platform. Okay, so next one, it can not only program, in fact complete operating system. It can run virtual machine like KVM in host CPU. So virtual machines, basically within one host you can have one virtual machine. Within that virtual machine you can have different kind of operating system. So installation is using this APT. You can install this QEMU system, and don't forget to use the APT update. If you see any error, then you can try with this fix missing. And so what is bootloader? So bootloader, you know, like I have taken example of this x86 because we know very well, everyone know very well this particular system. So it's like, and also some of that bootloader we will be using in the advanced system also from here. So it prepares the hardware for booting that software. Basic input output system is that our earlier used BIOS, everybody aware of that. Now it is moving towards UEFI. So let me go through another bootloaders also. For example, 8xx ROM. This is that initial bootloader for Motorola MPC 8xx that was later renamed as PPC boot, and ARM boot was merged with that. So then finally it became universal bootloader. So it is already supporting PowerPC, ARM, MIPS, a lot of other architectures, and x86 also. So we will, for simplicity, we will see the example of have a feel of this uboot in x86 architecture today. And Tiano Core is that open source implementation of UEFI, and that one, I will go through that detail. Other like Core Boot is another one that is basically earlier formerly known as Linux BIOS, and Linux BIOS, and this LibreBoot. So Core Boot and LibreBoot are basically aim to replace this proprietary based boot firmware. So let's see how this the role of bootloader here. Try to understand from that x86 booting mechanism. And what happens in that when you reset a hardware, power on reset, so first thing it will run a firmware, platform firmware, that is hardware platform firmware, which will be generally written in assembly or sometime maybe assembly and C also now with UEFI. And so in the BIOS system in x86, it resides in non-volatile memory and embedded in that platform itself. So that's why it is known as that firmware, and normally being provided by that hardware you purchase from that company. For example, if you purchase Dell based CPU, so Dell might have taken this firmware from some other outsource or whatever they developed. So it should be part of your system, and it prepares basically all testing procedure, power on self test procedure, the system prepare for that. You might have seen in the beginning memory test and all those kind of stuff. And it has interactive hardware configuration. I'm talking about BIOS right now. So once you press F2 or F12 depending on your x86 based system, you have the you can see like configuration comes, correct, system configuration. So you have the option of selecting, for example, booting order, or you can save the data as well. So that configuration is saved in the non-volatile memory. So boot mode can be like UEFI or CSM or BIOS. So those kind of boot mode will be there in the firmware. So after that bootloader, so what will be the role of the bootloader? Let me show you one quick thing here. So this is the figure. If you see that UEFI, unified extensible firmware. So this basically hardware, and this is the firmware, and then this extensible firmware interface EFI, it was developed by Intel, and that will basically load the operating system. So earlier before your Windows operating system, in fact I will say this comes to the prompt. So this is kind of mini operating system similar to you might have think of MS DOS we were using earlier. So this is one thing. And apart from this, let me quickly go through that. So after the EFI, then now unified extensible firmware interface, this is being managed by a forum. All the specification, it is written in C. So it is being used in other platform also. For example, ARM, it is being used. And so these bootloaders also depend on the boot partition format. So BIOS was based on the MBR partition format that has some limitation, master boot record disk partition. So new one is the GPT, this partition table. So because of this limitation also, sometime it is not possible like BIOS based or 32-bit system will not be compatible with the new UFI. So you can see like Windows 8.1 onwards it is UFI support is there, and I think there is UFI after 2020. I think BIOS will not be used. That is what being communicated. So UFI will replace that. So let me first try to understand that I will give you one demo on that how this BIOS, if you have this, you can take a control from BIOS. If you want to write your program, assembly program you want to try with, or you want to develop your stuff for some region custom based. So I have given very simple example here. So here BIOS loads program at this particular address. So this is the assembly written, the 16-bit mode, and you can see like here the clear that disable the interrupts. Then this is the message basically here. Welcome is that message I have written. So this SI is basically pointing to this particular custom data. Okay, then this tells the BIOS to print the character. So this whole thing basically does that character by character, this until you have till the last it passed to the this load byte to that L register, and it will print that, BIOS will print that, and then it will halt. And in the last, like here, because whatever the program has been written after that, this particular syntax will make sure that our assembler will make sure that rest of the 510 bytes were filled with 0. So this is the convention like current or starting of address. So current minus starting and 500 minus that. So that will be like the rest of the stuff. And here it's kind of magic number to recognize that this is a boot program. So we can see like how it looks like after we can use like NASM network assembler, open source software for x86, and you can install it using first of all you need to check whether you have to build essential or not. So you can always use this grep and check whether you have that. If not, then you have to install. After that you have to install this NASM, and then boot ASM, and format is bin, and output boot.bin will build your this basically boot.asm file, whatever I discussed, that will be converted to boot.binary. And if you are to see that what is listing of that corresponding code and boot, then you can use always this particular command. And finally you can check the binary with QEMU. QEMU system i386. So this particular is that emulate this i386 based system that has certain feature. It will basically emulate that boot.bin. I will show you this demo. And first let's look how this bin looks like. So this boot.bin will have only this much of code. Here my string will be also there, welcomes, and some of code in the beginning. And here in the last, in the 512, in the last in the of the master boot record, first 512 byte, in the last you can see the 55AA, so that it recognize it as a bootable code kind of stuff. After that, if you want to boot it using USB, you want to try with your hardware. So that good thing is that instead of as I told you that touching the hard disk. The good thing is that if our old hardware support the USB bootable mechanism, then we can burn in using that Rufus, like I have shown that particular format. And after burning, if you still want to check that how your partition table looks like and how you can read it from that USB itself, so you can always use in your this Cygwin in the Windows environment or any Linux based system. If you start Cygwin as an administrator, and you can use this particular command. So test.bin file, you will see similar hex file whatever we have seen earlier. So this is the way USB bootable format you can make. So let me show you the quick demo. So here, so my bootloader program is here, and I can check. I tried it. The bin file directory, bin file is already there. I have already compiled to save the timing. And let me try a command I was trying. Yeah, this is the command. So if I run it, so you can see like this message appearing here. So this message will appear. That's it. It will halt it here. So you can prepare a bootable USB and plug in there. So after that, you can do other initialization and modify your assembly. So a lot of stuff can be played on this x86 platform, and you can verify that always first here in the emulator, and then you can use the binary to actual USB and try that. So hope this will help. Let me move to another topic here, and next slide, and let me go to the next slide. So this one we have covered. So next slide is like uboot. Let's see how uboot looks like, and if you have not worked yet in a uboot, so you have an opportunity to try that uboot in this QEMU emulator. So as we have seen in our Linux earlier session about that git clone, I can use this git clone and this particular URL and go to this bootloader. Then first what you need to do, you need to export this particular configuration and make it like yes, and so that it will be environment set in that whichever folder you are inside this uboot x86. Then make this default config. It will create a configuration file for x86 QEMU x86, and then make all. So it will generate that uboot binary, then test uboot binary in the QEMU using this particular command, that you don't need graphics, and use this uboot.rom as a BIOS. So this particular command and net, you are using NIC interface. So those and net data I have given. So like configuration related thing, and let's see how it is here. I will go to particular. Let me go to particular folder, and uboot. I have x86. I created separate folder. There is the uboot, and here hold the setup. You will get this kind of file, and I have created here one source me folder, so that I can use source me also, or I can directly use this particular command, or I can write source me. So if I copy and paste this particular command, so your uboot is here we have the uboot now. So in the uboot you can try a lot of stuff. For example, bd info, first of all the board, whichever the board you have, in this case QEMU x86 system board, so it will show you boot parameter and all those kind of ETH address, those kind of stuff. Suppose if you want to try other command, you can use the help command, and you can PCI if you want to check the PCI. So based on that, from the website itself, you can check. I have given the reference of this vendor ID and all that also. I will show you that. So based on the vendor ID, this vendor ID is for Intel 8086, and the device ID and the bridge and all those kind of stuff. If you want to try something else, then help PCI, let's say. So let me show you PCI. Suppose if you want to check PCI, let me show you. Display is one command, and PCI header is another command. So let's say 0, from the top list we can see 0.1.0, 0.1.0. What is this 0.1.0? This is like bus device function. So you will see that a whole sort of detail, the PCI header, vendor ID, and all those kind of stuff. And not only that, you have other things also. Play with your, see the flash related detail, other USB related stuff, and those kind of things. Whatever is supported here, you can try. So this way you can have a feeling of how this universal bootloader looks like. And this uboot is being used in ARM, uboot is being used in RISC, uboot is being used in PowerPC, and now I have already shown you in the x86 and in the MIPS also. So it's like very useful information, and you can change that uboot source code here and try with the make all, and then simply emulate here without using any system, any external thing. So you will have very good understanding of this particular uboot loader working. And let me further and git clone, and this we have checked. So you may get, if you are building, if you get error due to absence of some required libraries, Python and all those kind of things, so you simply follow and install or Google, so you will find such. I got one or two errors, so I mentioned here, so that I found the solution. So otherwise it was cool. And references I have provided you, like firmware related information in the top, then UFI information I have provided you, that QEMU you can find out from where, and what the features of this QEMU system i386 we can look from this particular link, and PCI ID, whatever I told you, that is here. So if you found this information useful, please like this video and subscribe to www.youtube.com. See Embedkari, embedded career information. You can find at facebook.embedkari, and you can find that blog at that embedkari.com. Thanks for your time. Have a great day.